Greetings everyone. With the training of the church, calipers are precision tools used in workshops. Calipers are in three groups. The Vernier caliper is common, with various parts. It has a fixed and a movable jaw for measurements. Internal jaws measure inside holes. The Vernier has divisions for accurate readings. This part is the Vernier, identifying the caliper. The jaw can move to read measurements. Internal jaws measure inside holes, cavities, or gaps. The Vernier has divisions to read measurements accurately. This part is the Vernier, identifying this caliper type. Vernier calipers have a scale, but numbers may not be clear. We determine accuracy by the Vernier numbers and measurements. The scale is marked in millimeters and varies in size. There are some divisions that have been made, and these divisions and the decision of the church can be made. We call this part of the church, and we hear this church by the same title, minute. Vernier calipers usually have a scale, but sometimes the numbers aren't clearly written. However, we can determine the accuracy of the Vernier caliper by looking at the numbers on the Vernier and the measurements we take. The caliper scale is typically marked in millimeters and comes in sizes like 14 centimeters, 15 centimeters, 20 centimeters, and various other measurements available in the market. This measuring tool allows us to measure those holes, cavities, and gaps. 14 cm, 15 cm, 20 cm in various sizes are available on the market. Calipers measure holes and gaps precisely. They range in accuracy from 1/10 to 1/100th of a millimeter. Dial and digital types can read up to 1/100th of a millimeter. Calipers have varying accuracy levels from 1/10 to 1/100th of a millimeter. Dial and digital calipers can achieve 100th millimeter precision. The dial caliper uses a graduated scale instead of a Vernier, allowing precise readings. We read millimeters from the scale and fractions from the dial, combining them for the exact measurement. Its structure is similar to a Vernier caliper. Digital calipers also offer 100th millimeter accuracy, with millimeters marked for easy reading. It is designed as a graduated dial, which allows us to read with an accuracy of up to 100th of a millimeter. So we will definitely read the millimeters from its dial and the minutes from its hourglass. The total of the two numbers we read gives us the exact measurement we are looking for. The structure of the dial caliper is similar to the Vernier caliper we discussed, and the digital caliper is also considered one of the precise types, which can. The millimeters are marked directly on the ruler, so we can read them. On the digital display, we have both millimeter measurements and fractional measurements, which is 100 millimeters. With digital calipers, we have the option to set the 0 point wherever we want, meaning we can also use this tool for control purposes. Another feature that digital calipers provide is the ability to convert millimeters to inches and vice versa, which is done with a button located here. In some digital calipers, there's also a port that allows us to connect a cable to a printer, so we can print the numbers we read here. This way, we can keep a record of our measurements. But how is the accuracy achieved in different calipers? Here, you can see an example. To reach an accuracy of 2/10 of a millimeter, we consider 49 intervals from the ruler. If we count these now, there are 49 intervals. We divide these 49 intervals on the Vernier into 50 equal parts. We can print it out, which means we can keep a record of our measurements. But how do we achieve the accuracy in different calipers? Here, you can see an example. To reach an accuracy of 2/10 of a millimeter, we consider 49 intervals from the ruler. If we count these now, there are indeed 49 intervals. Now we divide these 49 intervals on the Vernier into 50 equal parts. So if we divide 49 by 50 and then simplify, I multiply the numerator and denominator by 2, which gives us 98 hundredths. I can place 98 hundredths here. We divide these 49 intervals, the Vernier, into 50 equal parts. So, if we divide 49 by 50, then simplifying, I divide his face and brain by 2. He gets 98 hundredths. Which I can put here. Subtract vernier from ruler scale for caliper accuracy. 1 millimeter, 0.98 meter, 0.02. I subtract the interval of the ruler divisions, which you can see here is 1 millimeter, from the Vernier scale division we calculated, which is 98 hundredths. When we subtract them, we get 2 hundredths of a millimeter as the accuracy of the vernier. To better understand how to read these calipers, for example, I have the caliper number here that I want to read. If you pay close attention, to read the caliper, we check the movable jaw to see which number on the ruler it has passed. Here, it has passed 70 millimeters, then 75 millimeters, and we say it's between 76 millimeters, 77 millimeters, and 78 millimeters. So 78 millimeters, then what?
The vernier 0 mark is at the last number passed on the ruler. The 0 was at 78, so 78 is our reference. To read the vernier, move right from 0 and check which line aligns with the ruler. The best aligned line is the measurement. I also count the previous line. This one is best. To read the vernier, move from the 0 mark to the right and find the line that aligns with the ruler. The best aligned line is the measurement. I also consider the previous line, and I believe this line is the best. This line, the third after number 3, on the vernier, corresponds to its lines. The second line is 5, making it 10, or 1/10. So this is 1/10, 2/10, 3/10. We have 32, 34, and 36 hundredths. This line is 36 hundredths, and this was 32 hundredths. This line, which is the third line, after the number 3 on the vernier, corresponds to which of its lines? The second line is 5, and the second line makes it 10, or 1/10. So this is 1/10, this is 2/10, this is 3/10. Here we have 32 hundredths, 34 hundredths, and 36 hundredths. If you look closely, this line is 36 hundredths, this was 32 hundredths, this was 34 hundredths, this was 32 hundredths, this is 34 hundredths, this is 36 hundredths. So the alignment is the same as the upper one. So our number becomes 78 millimeters and 36 hundredths of a millimeter. This is the reading method. Let's say we want to change the number. We want to read this number. Move left to see where the vernier 0 passes the ruler numbers. It has passed 50 millimeters and also 56 millimeters, considering 56. Move right from vernier 0. See which vernier line aligns. It has passed 1/10, 12 hundredths, 14 hundredths, and this is 16 hundredths. 16 hundredths line aligns with upper line. Zoom in for clarity. This is 16 hundredths line. 16 hundredths line aligns with upper line. Read as 56 millimeters and 16 hundredths. Let's see which vernier line aligns with the ruler. This one has passed 1/10, 12, 14, and is at 16 hundredths. The 16 hundredths line aligns with the upper line. To clarify, I'll zoom in. Here is the 16 hundredths line, aligned with the upper line. I read it as 56 millimeters and 16 hundredths. Some might say 18 hundredths is also correct. With high vernier accuracy, errors can be close, causing confusion. Some see it as 56 and 16 hundredths, others as 56 and 18 hundredths. You can read another number similarly. I read it as 56 millimeters and 16 hundredths of a millimeter.